it's very weird that it's now been a whole 12 weeks since last time we talked.
Time is what do they say in Doctor Who? A timey-wimey sort of thing?
Timey-wimey,
I'm not British.
biddly.
Neither are you. So British fans, please write in and correct us.
Exactly. Actually, come on the podcast and do an episode, and then you can correct us in the episode.
It's true. We always forget to mention that this is a community podcast. If you want to submit, just throw an audio file at us. We will happily host it if it's reasonably listenable and about Rust.
And to be clear, even if you don't have an audio file yet, you just have an idea, reach out to us anyway, and we might be able to help you make an episode. It's actually quite simple.
Speaking of quite simple, a thing that we should be able to handle is doing 2 Rust releases every 12 weeks. And we're working on it. We're getting there.
I mean, as far as I'm concerned, we're right on time.
It's true. It's true.
It's exactly 12 weeks since last I spoke to you, so we must be on time.
Shall we get into it then? Rust 1.70 is our current goal, our current target.
Let's do it. So first thing in 170 is sparse by default for crates.io. And this rings a bell from last time we spoke so long ago.
Last time we spoke 12 weeks ago, we mentioned that in Rust 1.68, this is a new feature that makes it faster to resolve dependencies for the first time on your system. And so if you're a casual user of Rust, you'll appreciate if you have a new computer the first time that you try and do cargo build, it will take much less time. And if you happen to use Rust on CI, it will take much, much less time because generally CI gets a brand new everything every single time.
And I think this even affects you actually if you just haven't run any cargo commands for a while. So they squash the index repo every now and again, which means that when cargo update runs or something equivalent has to fetch the index, it would have to do a full basically git clone again. And so it could now be faster for people who just intermittently use Rust as well, I think.
Yeah, that's true. Yeah, so previously in 1.68, this feature was implemented and you could opt into it, and now I think it is the default. So this is the new feature, is that it is the default for crates.io, and if you have any alternative registries, it should be possible to support that now too.
Yeah, so I think it is not set by default for alternative registries. It's possible to enable, but it's not on by default. Mm-hmm. And if I remember correctly, it's because of lock file handling. So technically, when you have a sparse index, the registry address in your lock file changes. And for crates.io, they can work around this because they know that the sparse index, the HTTPS URL, is actually equivalent to the GitHub URL. But for alternative registries, they don't have that guarantee. And so I think they're still trying to figure out exactly what should happen with lock files if you enable, if this were to be auto-enabled for alternate registries.
Right. I guess the idea is to prevent massive lock file churn.
Exactly right.
And a huge diff if you just enable this, which I guess isn't the biggest deal. But also I think the current recommendation is that if you have a alternative registry, you should probably support either one or the other.
Yep.
And then have your own kind of transition plan where you if you're a private company, you're using it all, hosting your own crates.io fork internally, just have a flag day where everyone moves over is probably feasible for you.
Or ideally, you even have some automation that could run it for you.
Mm-hmm.
The next thing here is OnceCell and OnceLock. And this, Ben, is something that strikes... I feel like I've seen these names before, OnceCell in particular.
Right. So OnceCell is a crate. I believe it's by Matt Clad, right?
I think that's right, yeah.
Matt Clad, the person who's the main author of Rust Analyzer. And so if you've used Rust, or at least, back in the day, one of the most venerable, oldest Rust crates is called lazy static, which is just in Rust, there are static variables, not variables even. I guess sure. Okay. Variables. Why not? There are static qualifiers. They are pieces of memory that you can kind of put up above the functions, global variables, but not quite, because Rust tries to discourage it. You can mutate them if you want to use unsafe code, but what's very useful about them is that they're kind of good for things that are scoped to the entire program.
Well, the entire lifetime of the program, really.
Right. Well, the entire lexical scope of the program. If you have some data you want to refer to during the program, then it's great to not have to pass those through to every single parameter list and every single function and thread them through all throughout. And so it's often very convenient to do this way. And if you try to avoid mutable global state, then that's great. But because not everything can live in a static, And so think a classic the example is a hash map, right? And so a hash map is allocated on the heap. And so when you're compiling the program at compile time, well, where does this live? Well, we don't know just yet because you haven't run the program yet. And so the alternative is lazy static originally, where the idea is it's just a macro that when the first time that you use a thing, it will check to see if the value is cached. If not, it will initialize it. And then in subsequent accesses, it will just use the cached value. And so there is a somewhat more modern alternative to lazy static called OnceCell by Matclad. And for a few years now, Matclad's been working on getting this kind of upstreamed into the compiler. Because if you look at, Crystal.io, these are some of the most downloaded crates ever. And so kind of like a very, very simple, very nice convenience methods or convenience features for lots of Rust code. And then hopefully one day you should be able to remove these crates from your dependency graph because you should be able to use the External library instead. Although, while the functionality is there, the fully ergonomic API isn't there just yet. What has been stabilized here, OnceCell and OnceLock, are kind of the primitives that you can use, and they're fairly nice, but they're not the exact, quite equivalent ergonomic API that you would expect, where you, so in lazy static, right, you have the macro, then inside you create your static, whereas with OnceCell, you have a lazy type where you have kind of like a closure inside and you initialize it. So with these currently, you with these types in the standard library, OnceCell and OnceLock, let's say for OnceLock, you have your static foo OnceLock, the type equals OnceLock new, and then later on in your main somewhere, you might want to initialize it and use it. Where now it's been initialized once, and so anyone can refer to it anywhere and not have to worry about initializing it or have to worry about using an unsafe block to set it unsafely. So that's the it's pretty cool, pretty useful, and I think honestly it's nice enough so far that I would just use it as it is. Although there's kind of like currently some bike shedding about doing the full lazy thing. It's definitely possible to implement the full ergonomic API. There's just some lingering design questions about future proofing and that kind of thing.
Yeah, and just to make it sort of explicit for those who aren't looking at the code, like if you're out walking somewhere or driving and you're having a hard time visualizing what this code might look like. So with the once type, so OnceLock and OnceCell, where you declare the static, you don't write any code for how to initialize it. Instead, anytime you access the static, you write, for example, foo.get or init, and you pass it a closure that will be called if it hasn't already been set to initialize the value. Otherwise, it returns you a reference to the value that has already been set previously. Whereas the hope, of course, as Ben was saying, with the lazy versions of these types, is that initializer, you don't have to spread throughout your code wherever you access the value, the static. Instead, you define the initializer where you define the static. But that's not a thing that we currently have.
And worth mentioning, too, that the reason there are two types here, OnceCell and OnceLock, is that one of these two is thread safe and one is not. And so obviously it's Rust. If you try and use the non-thread safe one in the thread safe context, it will stop you. And the reason this matters is because statics are all required to be sync, the sync trait in the standard library. And so if you try to do static foo for OnceCell, it would just say, oh, this is wrong. So that's why there are two. And so there are some, I guess, so for thread locals, it would make sense to use OnceCell. I guess Matclad also envisions using it within functions as well, kind of like at the top of a function. I'm not really sure why, but sure. Okay.
Yeah, I guess the argument, we talked a little bit about this earlier, that maybe this has to do with the ability to memorize function call, for example.
I think I was probably wrong with that. I'm not sure how that would even work, thinking about it more now. So who knows?
Yeah, but you could imagine that this is useful for something where that some part of the code that you invoke is going to set this variable, and then afterwards you want to just use it because it has been set, but where it gets set is sort of dynamic in some unpredictable way. Mm-hmm. And so you can imagine then using something like a OnceCell that you just pass on down and then pass back up, and then afterwards just assume that it's now initialized. Mm-hmm. But I do think that in general, we're going to see more use of this OnceLock type, which specifically is sync and can be placed in statics, than we will see OnceCell, which is probably more useful for something like thread locals.
Right, and the division between OnceCell and OnceLock kind of held up the stabilization for a long time, because how to name these things was kind of a difficult topic, where it's kind of, standard library has lots of various modules, and lots of the synchronous things live in standard sync in that module. And question is like, well, what do we name this? Do we have our own like lazy module for these? Do we like use the existing cell and sync modules? And so I guess the final solution was for like, OnceCell, it's like, we have cell is already not thread safe. And this is kind of like cell where like you have a thing where you set it, and then lock is meant to emulate RW lock. It's a little bit weird, right? So Jon was saying, right, it's kind of weird because you don't really think about like, locking or unlocking this.
Yeah, the once-lock isn't really a lock, or it is true that it's a value you lock once, which is when you initially set it. So in that sense, the name is appropriate, but it's not really a lock in the ongoing use of one. Like every time you call get, you don't really take a lock on a once lock. In fact, it's way more performant than that, which is an important property that the once lock has. The other, this is like a trend that we see every now and again of taking, common crates in the ecosystem and turning them into standard library features. So this now happened for OnceCell, and the other one that also happened in 170 was the IsTerminal crate, which provided a trait called IsTerminal that lets you take a file descriptor or a handle that represents a terminal or a TTY or whatever it might be, a file, and being able to call .isTerminal on it, and returns true if that file handle, if that file descriptor points to something that is in fact a terminal. And this is really handy for command line interfaces, for example, where you might only want to use colors in your output if you're facing a user, like it's something that's being displayed on screen, and you don't want to do so if, let's say, you're printing to a file. And so there was this crate IsTerminal that people were using for this, and it's such a straightforward and also commonly used tool in command line programming that I guess they decided eventually just adopt it into the standard library. There used to be a crate called ATTY, which did the same thing, and then I think went unmaintained for a while, and so that caused some issues, and then everyone moved to IsTerminal, and so I think the conclusion here was this is clearly such an important functionality that we can also provide very simply. There's not a lot of debate about exactly how it should be exposed or implemented. Those are both fairly obvious, and so they did so, and now it's available in 170, which is really nice. It lets you reduce your dependency closure by one more.
Yeah, I'm a big fan of taking these kind of like small convenience crates and just being like, well, this would be it adds very minimal maintenance burden to us inside the library. It's kind of a simple thing to add once and forget about it. So let's just upstream that and then make it here forever.
Yeah, it's nice.
I'm a maximalist.
The next thing is that we now have named levels of debug information. So you might have seen this in the past where either in your cargo.toml or in your Rust flags, you set debug info equals 1 or debug info equals 0, or debug info equals 2. And these numbers are a little bit obscure. Like, what does 1 mean compared to 2 when you set debug info in your cargo.toml is not entirely obvious. So these levels can now be set by name. So instead of 0, you can write none. Instead of 1, you can write limited. And instead of 2, you can write full. And there are also now 2 new levels called line directives only and line tables only. Now, this only helps you if you have some idea of how debug info is actually encoded. The basic distinction between these is that none is essentially no debug information. So you don't store things like function names, variable names, arguments, just nothing. Full is, as the name implies, all the debug info. So basically everything that the compiler knows about the compiled code and how it relates back to the original source code is stored in the debug info. And then limited and this line directives only and line tables only is a little bit more convoluted. So the idea here is to include, so limited here includes information about all functions, types, and variables. But then there is also this thing called line tables only, which is reducing backtraces even more so that it just gives you what's needed to get backtraces that has file names and line numbers. So it only really tells you like which file, which line, and doesn't store anything about function names or anything, which is often enough for you to figure out what the backtrace means and where the origin was, while still significantly reducing the size of the debug tables. And then there's this line directives only, but that's apparently only for very specific type of profiling. So it's not generally something you'll run into. But at least now these have names rather than just numbers that you need to go look up somewhere.
Up next, there's enforced stability in the test CLI. I'm sure that you're aware that there's a stable and unstable sides to Rust. If you want unstable, you use the nightly compiler. If you want stable, you use the stable compiler, obviously. And so this also applies to the CLI. And so the language itself obviously has its own kind of stability enforcement mechanisms. And then for the Rust C CLI, even cargo CLI, there is a flag that you're supposed to be using if you want to opt into any of the unstable stuff, knowing full well that it might, eventually break or change in some way because, unstable. However, for a while in cargo tests specifically, there was a bug where a certain thing wasn't being flagged as unstable and was being permitted on the stable branch. And that was for certain JSON output for the tests, for all the test functions that you compile in your program. And so this was being used by various tools. And so because we're a bit late with this, I'm sure that by now, if there's any breakage from this that you've encountered, it's already been addressed in your tooling or your IDE, et cetera. But it's kind of like one of those things where the goal currently is to stabilize the actual JSON interface for all the cargo test stuff to make it so that eventually tools can actually rely on the stability of these interface. And I believe ePage, who is the main cargo person right now, is currently actively working on stabilizing the JSON output of all the cargo and I think even Rustock stuff too. So look forward to that. And in the meantime, some accidental breakage for things that should have been unstable and then
it should have been unstable
enforced
all along. Yeah,
they were unstable but weren't being enforced. So now you have to actually use the -z unstable options flag if you want to get them, which is only available on nightly.
There's also a whole bunch of stabilized APIs in this release, and the first sort of chunk of them is a bunch of implementations of the default trait for various iterator types. So for example, there's now an implementation of default for std-vec into iter, which is the type that you get back if you take a vector and call .into_iter on it. And I did a little bit of digging to figure out, like, why does this matter? Who cares whether the iterator types implement default? And it turns out that the reason why it's handy is because imagine you have a struct that ends up having to hold one of these iterators, either because it is also an iterator or because it's just a type that does some operation, and the way that it gets the sort of the input that it's going to like get work from or something, then it has to store one of these. But at the same time, you might want that type to implement default. So you might try to derive default on it. Well, you can only derive default on it if all of the fields implement default. So previously, if one of those fields held something like, a B-tree map iterator or vector iterator, then you would be out of luck because they did not implement default. But now with these implementations of default, that kind of derived default is just going to work. And the rule they've set themselves is that we should only implement default for iterators where it's obvious that the iterator should provide an empty iterator, like it should immediately return none. So default for std-vec into iter, for example, returns an iterator that has no elements, because that would be the same as calling .into iter on a default vec, which is empty.
An API that I want to bring up was RC into inner and ARC into inner. So these are both into inner methods on the RC and ARC types, the smart pointers, where the goal is here, into inner will return the inner value contained inside the smart pointer if the reference count is exactly 1, or one strong reference, because there's also weak references which get ignored naturally. Otherwise, if there's more than one strong reference, it will drop this RC and return none. And so basically the idea here is if you want to kind of extract a value, if you have several RCs, which you probably do if you are using RC, and you want to extract the value, previously, if you wanted to do that, I guess the best way to do that was to use try unwrap .ok in a loop over and over again. But because of race conditions, that could actually, I think, deadlock, right? Is that the downside there?
Yeah, so the problem with try unwrap is that if it fails to unwrap, if it fails to extract the inner type, as in if the strong count is more than 1, then it returns the arc that you passed in the error condition. But as a result, the next thing you have to do is then call try unwrap again, or to drop that error. But there's a condition there where you might end up with no function or no call actually ever getting back the OK value. They might all just end up spinning on which of them ends up, like, anytime any of them try to unwrap, they see the number 2, and then they both try again and they see the number 2, and you're never guaranteed that exactly one of them is going to get the value back.
Yeah, so this does now actually guarantee that if you call into inner on every single handle of the RC, exactly one of them will return and the rest will return none.
Another one that I thought was pretty fun in this, and that's partially because that has a little bit of history, is the stabilization of the method isSum and on option, and isOK and isErr and on result. These are semantically equivalent to having an option and calling .mapOr true and then a closure that returns a Boolean. So the idea here is that if you have an option T, then you want a method that returns true only if the value is sum, the option is sum, and the value inside the option matches some condition. That's when you would use this function. And so it saves you maybe a letter or two, or maybe actually no letters compared to map or true, comma, but it does make your intent a little bit clearer, which is this returns true only if the option holds a value for which some condition is true. So it's nicer to read in something like an if, or in something like an iterator any or iterator all. And this was actually proposed, I think, several years ago, and it's just taken forever to be stabilized because there was so much disagreement about what the name should be. Do you have some of the names handy, Ben?
I have a list compiled here. Do you want to read all of them? Do you want to get some tea while I'm reading these? Different names that were proposed.
Well, but maybe pick some interesting ones.
Contains some, has, includes, contains in, eq sum, wraps, is, map contains, contained is, inside is, PEQ, equals, sum and is, where, having, and with, sum with, and if, contains with, test, any, has with, exists, sum if.
Wow.
And so, I mean, I like how it currently ended up with. I'm actually like, I missed the entire bike shitting there. And I appreciate the final name because it seems to me like, it returns a bool. You're going to use it in a kind of a Boolean context, like an if. And so if you're a person who uses, if, is sum, so if foo.isSum a lot, and you want to, like, you had like an inner if where it's like, well, also want to test on this, it's kind of just a nice convenient thing. And so it seems like they chose the right thing.
Yeah, and it reads pretty naturally, right? Like foo is sum and some closure.
Yeah.
And it reads somewhat like English.
Bike shredding sometimes, produces some nice results.
It's true.
Even if it's wholly intolerable.
And then another one that I wanted to bring to the fore is this socket adder ext. So in the std.os module of the standard library lives a bunch of things that are operating system specific. This is stuff like additional methods on sockets, additional methods on file descriptors, all sorts of things. Like, for example, on Linux, what lives in there is the ability to create an OS string from a UTF-8 string. Or even just from pure bytes, I think, which is not something you can do on Windows, for example, because OS strings are UTF-16 encoded. So that's a Linux-specific capability that lives inside the std.os module. And one of the things that came with 170 is there's now the socket adder ext extension trait for socket adders. And the primary thing that they give you is the ability to create socket addresses. So these are just ways in which you can name network endpoints. And you can now create them from names, which is used in Linux for things like Unix datagrams or pipes, like named sockets. So these are things where what you actually have is a path, for example, rather than having an IP address. And previously, you basically had to either do some manual syscall stuff or use an external crate. And now you can just do it directly in the standard library. And this is arguably the standard library's job, right? Is to abstract away or implement operating system dependent behaviors and surface them in a nice way, which they're doing now with socket adder ext.
Any juicy things in the detailed release notes?
Oh yeah, always. So one of them is that in 170, and this was interesting to me, they decided to downgrade the version of SIP-hash. So SIP-hash is the hashing algorithm that Rust uses internally when you use like the default hasher for hash maps or whatnot. And they were using SIP hash 2.4, and now they're going back to using SIP hash 1.3. And that might seem strange until you realize that the main difference between them is that SIP hash 2.4 provides stronger security guarantees about the hash. In particular, it provides things like denial of service resistance rather than just collision resistance. And Rust doesn't need this because they already seed the hashes for hash maps with the random value on each start. And so they don't also need the hashing algorithm to implement that kind of resistance in addition. And so they found that by switching to this simpler version of SIP-hash, like I think they see performance improvements along like around 2.5% across like all compiles in the big benchmark suite that they have. And it also obviously has effects on other runtime code downstream of the compiler. So it's not just building crates, but also running them should be faster now that the default hashing algorithm is faster.
Also worth mentioning, too, that if you want maximum speed, you don't need the DDoS resistance. You should be using a faster hash for the purpose.
Yeah, like the A hash crate or something. The other thing from the detailed release notes that I thought was interesting is there's now alignment checks for pointer dereferences that are automatically turned on when debug assertions are enabled. So basically in debug mode. And the observation here is that whenever you try to dereference a pointer, it has to be aligned because Rust requires references to be aligned. And previously, this wasn't checked by the compiler, but now, sort of similar to out of bounds checks, they're now going to check every time you try to dereference a pointer, it's going to check that that pointer is actually aligned before doing the dereference. And otherwise, it's going to panic, just like an out-of-bounds error would do. It will only do this in debug mode, so it shouldn't affect you in release mode, and the overhead of doing this checking shouldn't affect you in release mode. But hopefully, this is going to catch some cases where people weren't aware of this rule or weren't upholding this rule and weren't otherwise testing for it using something like Miri. There was one other thing from the standard library I thought was neat, which is the assembly macros. So ASM and global ASM used to be very strict about the order in which you needed to pass in arguments. And with 170, that order's been relaxed a little bit. So now there's still some ordering requirements, but some things can appear in any position. And apparently the reason they changed it was mostly because people were having macros that generated assembly statements. And when you do that, sometimes it's hard to make sure that the input or the order of the code you generate is actually follows these rules. And so being a little bit more flexible about the order when it's permissible, like it's still unambiguous what you intended, just makes things a little bit easier for macro authors. And then the last two things I wanted to highlight, these are nightly things in Cargo, but I just wanted to highlight that they're sort of coming down the pike. One of them is the Gitoxide feature of Cargo, which is basically someone's re-implemented all of Git in pure Rust. And this is a way to switch to the Gitoxide implementation of Git for all of Cargo's Git operations. And it's still coming along, but it can be really fast. It's a really cool effort. The other one is Zdirect-minimal-versions. So this is similar to the -z-minimal-versions flag that you can use with Cargo Update to update your lock file to be the earliest version of all your dependencies rather than the latest, useful for things like testing older versions of your dependencies. Direct minimal versions is the same thing, but it will only choose the minimum versions of all your direct dependencies and then the maximum versions of everything else, which should make it a little bit easier to do this kind of testing in the face of an ecosystem where people haven't traditionally been testing with this flag.
I wanted to mention about the Gitoxide thing. I'm pretty sure that's Byron Bates is the one working on that, and extremely brilliant, hardworking, and is being funded by the Rust Foundation. And so if you're out there working on Rust stuff and you're looking for funding for things that will benefit the Rust project, the Rust Foundation does give out grants, so you should seek that out.
Shout out to the foundation, huh? Okay, let's move on to Rust 171. So for 171, the first thing that's highlighted here is the C-unwind ABI. And this one I had to go do a bunch of reading before I could talk about it in any reasonable fashion. And part of that is because there's still some undecided bits in here about what exactly this is going to mean longer term. But the basic premise is currently, as in Rust today, prior to 171, when you declare a function as extern C, you're basically not allowed to panic. You're not allowed to panic in the function. so that panic goes out to any cross-language callers of your extern C function. And you're also not allowed to sort of take panic. So if your extern C Rust code calls another function over FFI, that function is not allowed to panic or unwind, rather. It's not allowed to unwind into you. Basically, unwinding and FFI did not play well together with extern C. And one of the things that this is sort of an effort that's been going on for a while is they really want to allow you to unwind across FFI boundaries. And there are ways to do so safely, at least in some situations. But at the same time, they observed that most of the time, unwinding across FFI boundaries is something you want to be really careful with for things like if you have unsafe code, for example, there might be additional properties you want to uphold. And so they actually kind of want to make it so that if you panic across an FFI boundary, that you get a panic or something that highlights that something went wrong, but they also want to enable you to have unwinding across FFI boundaries if that is the behavior that your code is written for and that you actually desire. And so with 171, they've now stabilized a new ABI variant where you can write extern C-unwind. And the C-unwind ABI is exactly like the C ABI, except that you are allowed to unwind across both sort of into and out of those kinds of extern functions. There's a little bit of interesting interactions here. Like if you've set panic equals abort in your configuration, then with C-unwind, panic inside of an extern C-unwind is going to do an abort. And if you call an FFI function and it unwinds into you, then that also causes an abort when you set panic equals abort. And currently, the behavior, if you use extern C and you have panic equals unwind, is that you get undefined behavior in a bunch of these cases. But that's something where longer term, they want to improve that situation and give you an abort instead, because that's easier to reason about. But that's not something that is currently present. It's something that they're kind of working on to get better behavior by default, or not necessarily better behavior, but to avoid the unexpected and undiagnosed undefined behavior when you're using just extern C and unwinding happens. Which actually reminds me, maybe we should talk about what unwinding is. I don't think we've done that before. Do you want to try that, Ben?
Well, to what degree? So unwinding, so if you're familiar with Java or Python or anything, the idea is you encounter an error and then something happens, and then somehow control of the code moves to, so you have in say Python or Java, you'll have a try except kind of thing. The syntax differs, right? And you'll be doing an operation and then, something went wrong, and it'll then jump to a catch block somewhere. And so somewhere else in the program, you'll have a block that says, okay, if in the previous block, any kind of error occurs, any kind of exception occurs, we'll jump over to here and then continue on with, data on the exception. And who knows what will happen at that point. And so unwinding in Rust does not have a facility for this kind of it's funny, right? Because it's tempting to say that Rust has unwinding, therefore it has exceptions, but exceptions are more than just unwinding, where unwinding is generally technically considered to be the part of the implementation that allows you to kind of walk around and move control flow to a catch block. But what Python and Java, et cetera, have are probably what you'd call resumable exceptions. So the idea there is that you're using exceptions as kind of an error handling mechanism where you want to catch the error and then continue on with some information, or at least potentially continue on. Where exceptions are kind of handled at error point, and then I can either throw them up even higher up the stack, right, or handle them here. In Rust, unwinding is for panics, and so it is the same kind of mechanism under the hood as used in Java or Python, where it kind of walks back up the stack to find out where it should go. But the difference is that Rust does not really want you to try to catch that panic. There is obviously a catch panic function that allows you to do it, but the reason it exists is for this specific purpose, which is that it is undefined behavior to unwind across ABI boundaries. And so if you want to be correct, if you're writing a Rust crate that is called from C and might cross into C, you want to stop the unwind before it crosses the boundary, just to be safe for the people who might want to call your program. And so because of that, there is this catch unwind function. But that's really the only reason, the only, quote unquote, supported way to use this function. It does, you could imagine in theory someone using this, quote unquote, using/abusing this function to create their own kind of resumable exception facility, like in Python. But Rust has results for this, right? So if you want to handle an error at the site of a certain thing, you would, instead of using this unwind facility, you would just use normal control flow and then handle it wherever you want to handle. You might, or either you're using the question mark operator to propagate the error, or you're just using a match block to handle it right there, or using any of the combinators and, etc. On the result, Rust gives you it's called errors as types, I guess is the general way of describing it, where, errors as values it is, right? So the error is a value. It's not some kind of exception thing that happens parallel to the code.
Yeah, it follows the same flow in a sense.
Yeah. And so there are pros and cons to both approaches. But the point is that, and so Rust supports unwinding. And the reason it does, you say, there's unwinding and there's aborting as both valid ways to panic. Why does Rust support both? And the reason is that, if you are, say, a guest in some kind of process and you don't want to bring down the entire process if your Rust code panics, then you'd want to have some way to catch the panic, right, and stop it and prevent that from happening. And so this is a nice way of if you are writing a plugin for a thing, or if you, I think, it's so it's named Servo, right? And if you have a Rust process or a Rust task that crashes somewhere in one of your tabs, then you don't want to bring that into the entire browser. You want some way to isolate the failure and then restart it in a different way, in a controlled way, that is. Is it answer your question, John?
Yeah, that's great.
Hold on. Before we continue, the guy has told me that the next person is here. So I have 5 minutes left. So hopefully the editor can go through and.
I think we'll be okay. We'll run through the last of the main bits, and then I'll do detailed. Okay, so the next one here is debugger visualization attributes. So these I can do pretty quickly. This is basically a way to specify for some type that you define how it should be printed by something like GDB, like by a debugger. So normally when you run GDB or this NatVis, which is a Microsoft thing, if it encounters a type it doesn't know the definition of, it just prints all the fields to the extent that it knows that from the debug info. And this lets you actually write a program that dictates how that file should be printed out. And so Rust has this for a couple of standard library things, but now other libraries can use it too, which is going to be really nice. And then I'll do the next one too, because this one's pretty straightforward as well, which is raw-dylib linking. So on Windows platforms, Rust used to basically require that in order to build a crate on Windows that linked with a system library, you had to have that system library installed at build time. Whereas now, all you really need to have available at build time is the header definitions. And then at runtime, you can dynamically link in the sort of DLL, and then the symbols will be resolved at that time instead. This is using the link attribute kind equals raw-dylib. And then there's the musl upgrade. Do you want to talk briefly about the musl upgrade?
Right. And so musl is an alternative libc. So whereas libc is on Linux, like OS's, kind of the interface to the OS, but it does not play nicely with static linking. And so generally in a Rust program, everything is linked statically, with the exception of libc, if you're on Linux, right? So if you want a fully static binary that does not have any kind of dynamic dependencies whatsoever, the solution is you use musl, M-U-S-L, which is an alternative libc, which is static linking friendly. And so there are new releases. In particular, I think this release adds 64-bit time support. So it means that you can actually use times that won't wrap over in 2038. So, 15 years.
I'm so excited for the 2038 time crisis.
It's going to be a fun time. The time crisis.
Yeah.
So that's what's happening here. And so anytime you upgrade any kind of these system libraries, it can be traumatic because lots of they're not generally right. They can make breaking changes in ways that are kind of people aren't really prepared for. Right. So it's going to 1.2.3 from, I don't know, 1.2.2, or is it 1.1 point something?
I think it's moving from 1.1.
Anyway, the point is, it's not Semver. There is a breaking change in here, and I believe honestly, it's probably predates Semver, honestly, so it's not their fault. So a thing to watch out for if you're linking with musl.
And then I think the last sort of main body of 171 is this const-initialized thread locals. And this was accidentally stabilized in 159, but it doesn't actually they didn't actually tell anyone by accident that they released this. And so this is just the ability to say, if you define a static, especially in thread locals, you can say pub static foo :type equals const and then curly brackets, and then actually write a block of const code. You don't have to write just like single function call that is a const function for initializer. You can actually write a block of code as long as that code is all const. And so you've had this ability since 159, you just didn't know it.
Right, and so the idea to put code inside these const blocks is a kind of long-standing feature that's been in development for a while, and it is coming, but I believe it's currently blocked on some bike shedding for syntax stuff. So I believe it can be stabilized here because thread local is a macro, and so it's already kind of rewriting syntax, and so if there were any problems internally with syntax, it would be able to address those. Same kind of reason why I believe that ASM should at some point be able to do this kind of like const operands kind of thing prior to const expressions being stabilized. That's the hope anyway for all of us who use ASM.
Oh, because it can just rewrite the syntax?
Yeah, because it shouldn't be force a breaking change if the syntax ends up changing in some minor way.
Nice. I think that leaves us with the detailed release notes, which means that now that you're being kicked out of the room,
I'm being pulled away. The library can only abide me for so long.
That's right.
So farewell.
Ben has chains attached to him and is being pulled away. So I will do my deep dive alone. Okay, so in the detailed release notes this time, I thought there were a couple of things that were worth highlighting. One of them is a clippy lint that's being uplifted into a real Rust lint. It's grown up. It's become a real boy. So these are the drop ref, drop copy, forget ref, and forget copy lints. They've been in Clippy for quite some time, I think, and the intention here is to notify you if you are calling the drop or forget functions on things where doing so does nothing. Something like, imagine that you take a lock, so what you get back is a guard, and your intention is to drop the guard, but you're actually dropping a reference to the guard, and so the guard ends up still living, but you don't realize that you are dropping a reference, as you don't realize you're still holding the lock, and so this lint would tell you, no, right here, you're dropping a reference when you intended to drop the actual guard, and so this is probably not what you intended to do. And it's done really well in Clippy, and so it's expected that it will do well in the compiler as well. Another thing that I thought was interesting in the detailed release notes of 171.1, 171.0, we'll get to 171.1 later, is that now it's actually possible to have a recursive panic. So we've talked a little bit in the past about how Rust doesn't allow you to panic during a panic. If you do, it immediately aborts. But now there's one exception to that, which is, imagine that you're panicking. And in the code that runs during the panic, so in like the drop implementation, for example, for a type that was held where you did the panic, that drop implementation calls catch unwind, and the code inside of catch unwind calls panic. Then now, technically, this is a recursive panic, but that inner panic is caught before it unwinds all the way up the stack as well. And so in this particular case, it is actually okay to have a nested panic. And so this is something that was now enabled with Rust 171. I'm not exactly sure where this comes in handy. Maybe it has to do with if you have things like FFI calls, where it might actually make sense that you have a catch unwind during drop that internally panics. But I thought it was interesting regardless. There were also a bunch of improvements to cargo in 171. The first of these is to optimize the interaction between cargo and rustup. In particular, if you installed Rust using rustup, what actually happens is that the cargo binary and the rustc binary that are on your path, like when you type cargo or rustc on the command line, are both actually point to rustup. And then when you call them, rustup looks at your configuration and everything and figures out which real binary to call, like the one for stable or beta or nightly or whatever. But where this gets awkward is, imagine that you call cargo build, and cargo build calls into rustup, which calls the real cargo build, and then it needs to compile all of the crates that are in your dependency chain, which means it needs to call rustc a bunch of times. if every Rust C invocation has to go through the same wrapper, it's really, really inefficient because you're already in rustup, so it already knows your configuration. So with 171, that use case was pretty significantly optimized to make it so that if cargo detects that the Rust C that it will choose should have been a rustup proxy, then it will instead just call the real Rust C directly rather than going through itself again. And there are a bunch of caveats here to try to make sure that there's no regressions where people relied on the fact that the inner Rust C invocation might actually have a different rustup configuration, for example. I'll link the detailed description that's in the PR for this. It's a pretty interesting, hairy problem, but it's exciting to see that they've been able to land this. They've tried this in the past, and this should potentially significantly speed up some builds where you need a lot of recursive calls to Rust C. There was another optimization to Cargo where Cargo would, when it talks to a registry, it would try a lot of different combinations of dashes and underscores to make it so that even if you wrote a crate with the wrong, of dash or underscore, it would eventually do the right thing. But it was doing so a little bit too aggressively, which meant that it would cause a lot of requests to the registry, even in cases where it was impossible for that particular combinations of dashes and underscores to appear in that path to the registry. There are a bunch of details for why exactly this matters, but the interesting takeaway is that Cargo should now be faster about accessing the registry whenever you have dashes and underscores involved. I think it's specifically when dashes and underscores are in the first 4 characters of the name or something like that. Another one that people might be interested in is that as of Rust 171, Cargo will now include the Rust version from cargo.toml in the publish requests that it sends to the registry. And this is useful because it starts to pave a path for getting something like Rust version aware cargo resolver is for the registry to also be aware of things like the Rust version. It is technically contained within the .crate file that's uploaded, but this makes it a lot easier for the registry to access that information. The other thing I thought was neat with 171 is that Cargo got a bunch of documentation updates specifically around semantic versioning and the rules about what is and isn't a breaking change, which are documented in part in the Cargo book. I'll link that page as well in the show notes. And we won't go through the details of all the changes, but many of them came from the GitHub user Obi-Wan Kenobi, who's also known as Predrag Gruevski, who's built Cargo Semver checks, which is a tool that will tell you if you have breaking changes between 2 different versions of your source code. And it does this by essentially diffing the before and after and then comparing it to all of these rules that they've encoded about what is and isn't a breaking change. And so part of this is identifying, places where maybe the documentation doesn't say, but the community has accepted that something is or isn't a breaking change, and then bringing that back into the documentation and ensuring that it is properly documented. And then the last thing that I think is on the books for today is Rust 171.1. So this was a point release for 171 that fixed a security issue in Cargo. And the security issue is actually pretty straightforward. So when Cargo downloads a dependency in order to build it, it downloads that as essentially a tarball, a zip file of source code. And then it extracts that source tarball, and then it runs the build on it. Now, the challenge is that, or what Cargo did wrong here, was it would download that tarball and then extract the files using the file permission bits that were set by whoever uploaded that source file. And what this meant was that if I, on my local developer system, had marked, let's say, my source files as being writable by anyone. So in Linux terms, like have like 777 permissions or 666, so they're writable by even people who aren't the current user. And then when I run Cargo publish, the file that ends up in the tarball that I upload to crates.io would have write permissions for everyone. And when people downloaded and extracted that file would have write permissions for everyone. And this is problematic, right? Because Cargo will generally reuse the sort of cached extracted folders for all your builds. And so that means that if that file is modifiable, someone who's not my user but has access to the same machine might be able to go in and modify the contents of those source source files to make it so that they contain something else, something potentially malicious, so that the next time I build my source code and Cargo sort of trusts the contents of the cache, it would actually build different source code than what was really uploaded for that crate. And so the fix here was to make Cargo respect something called the umask, which basically configures which bits should be cleared whenever you create new files. And so that way, things like the writable by anyone bit would be cleared when Cargo now extracts these tarballs. And that, I think, is everything we have for this set of releases. And it feels weird to be in this empty room without a Ben. He's been chained, he's been pulled away from me, and so I'm stuck here all alone, waiting for the next 12 weeks until next time. Ben. Well, hopefully he'll be back in 12 weeks and he hasn't been banned from the library. See you all later.